Welcome back to R for Economics. We'll be talking about expressions, derivatives, and second derivatives and higher order derivatives in this one, and how to evaluate them. So the first thing we can look at is what's called an expression. So we can have a function here of y's and x's, and we can call that an expression. And if we do this and run it, we can see that it says expression, all this stuff. So we can assign that to a variable and expression. We get the same thing again. The class is actually an expression class. Okay. So to take the first derivative, now that we've got an expression, we can now take the derivative with respect to, let's say, y. Okay. And the d function is actually taking the derivative. So if we take the derivative, we can see that the the derivative of that is just going to be itself. And then we're going to have 3, and then we take the derivative of 3 to the power 3, which is multiplied by 3y squared. Okay, so it was able to take that derivative pretty easily. Now, what about taking a second derivative? Well, we just need to do it again. Now, our class of an expression 1 is a call. So it's no longer an expression, it's now a call. So what we need to do is change it. Even though it's written out and looks like an expression, we have to actually call it an expression. So we need to say as an expression, so now it's got expression in the brackets, and that says that this is something which is encapsulated, this is a function. And then we can take the derivative with respect to y. Now this is already a derivative, so we want to have the second derivative. And now we can see what the second derivative, well, the exponent of y, the derivative is just itself. And then we have 3 times 3 times 2 times y, because the derivative of y squared is simply 2 times y. So these lead to bulky expressions, but they are the derivatives. And not all of the derivatives can be done. Some of them are restricted because there's no easy way to do it. But a lot of the expressions that most people will use will be that. Okay, so let's say we wanted a higher order derivative. So we wanted to have an expression, the name, so that's the name is y in quotes, and then we have our order is equal to 1. So we need to set our order. So if our order is less than 1, so 0, then we just stop and the order must be greater than or equal to 1. It should just return itself. Now if we have the expression is equal to 1, then we just take the first derivative. If it's a higher order, and our order that we want is, let's say, 5, then we're going to say, well, I'm going to take the order, and I'm going to go through and take the derivative with respect to that with this name, but then I'm going to take this higher order derivative. And it'll continue doing this derivative because this is its own function until it's completed. So let's define our expression, and now we're going to do to the derivative 3. So this is going to go through and say 3, well, that's definitely greater than 1, and I'm going to do this. Oh, I'm going to call dd again because even minus this, it's 2, and then I go on until I get 1. So I keep on doing this derivative until it's complete. So an order expression, and we can see that this is the same is the derivative of this one up, this expression 2. And we can see the derivative of y is simply 1. So now we have our expression order. And we can see that this is also a call function. Well, a call function, can we just evaluate it? Can we just say, oh, how do we evaluate this thing? Well, we got to use the eval function. And we have to define our values x and y. And we can evaluate the expression, and then its derivative, second derivative, and now we have the third derivative, and so on and so forth. So if we went to the fourth derivative, it would just be the exponent of y, so the exponent of 3. Okay, so that's how you take the derivative, expressions, and higher order derivatives using a function variable, and you can evaluate it. See you in the next video.